Okay, so we are moving into the very last column on your green paper, right? Solving more than two fractions. So you're going to have like fraction equals fraction plus another fraction, or there's another number, or there's just something else there. It's not just fraction equals fraction anymore. So what we are doing is they call it the LCD method, least common denominator. You can call it what you want. I just call it solving. But here's your steps. So first step, you will factor denominators. Are you factoring the numerator? No, just the denominator. You will find the LCD. Have we had practice with that already? Yes, we have. Now, before, when we were like adding and subtracting and we found common denominator, we multiplied by just what it was missing, right? Because we wanted to get them to be the same. This time, our goal is to get rid of all of my denominators. So this time, once I find my LCD, you're going to multiply the numerator by the LCD, the entire LCD. Not just the missing piece this time, but the whole thing. Because what's going to happen is you're going to cancel your denominators out. If you don't cancel them all out, you did something wrong. Right? Then you'll solve for x and check for extraneous. So after step 3, if you still have a fraction, it's wrong. Okay? I don't want fractions. I want to get rid of them entirely. So here we go. So number 1. So notice how it's not just fraction equals fraction, right? See that extra little pesky 7 that kind of snuck right in the center of that? Messed up everything. So step 1, factor denominator. I don't have a denominator, right? There's nothing to factor. What's the denominator on that one? That's just a 1. Do I really need the 1? No, I really don't. Find the LCD. Good. The LCD is just going to be x minus 2. Right? If you were getting common, that's what you would make them all. But this time, I multiply by the entire LCD. Now, this is going to seem obnoxious to some of you, but I'm going to tell you I still do this to this day because it's so helpful. You are going to multiply all of them, every single piece, every term, by whatever your LCD is. You're going to write it down on all of them. All right, we got to be fair. We got to be balanced. If I multiply one of them, I have to multiply all of them, right? It's like my 3 kids, right? If I do it for one, I got to do it for all 3. Now, I told you step 3, when I'm multiplying here, the point is to cancel your denominators out. Take a look at that first fraction. Do you see something on top and bottom that cancels? The x minus 2? Now, I showed that I was putting the x minus 2 on everything. That had to balance, right? So look what happened to my denominators. They canceled. So what's left? 5x equals. Now, what happens on this term? Does anything cancel on this one? No. So I actually have to multiply that one. So I have 7x minus 14. And then the third term, the x minus 2 cancels. So I get plus 10. Look where my problem started, and now look where I'm at. Isn't that a lot nicer looking? Okay, you guys with me so far? Again, we're baby stepping, right? We're starting with some of the easier ones. All right, from here, I just need to kind of clean this up a little bit. So I have some like terms going. So that gives me negative 4. Do I have to set this equal to 0 to solve? No, I'm going to solve like normal. So I'll move that over and get negative 2x equals negative 4. So x equals 2. Am I good? Did I follow all my steps? It's wrong. What's wrong? Yep, your extraneous solutions. What's your only restriction in this problem? 2. So what do I say? I don't say wrong. I say no solution. I was right. It's just there is actually no solution. There's nothing that works. Robert, you okay? You have a very deep in thought look going on right now. Think you're okay? All right, we'll do the next one. If you have questions, let me know. So number 2. So step 1, factor denominators. Do they factor? No, they're just monomials. So find the LCD. What is your common denominator? It's just 2x. So I have to multiply, and again, I do this on all of them. I think it really helps to visually see. I'm being fair, I'm keeping it balanced, I'm putting it on every single term. And then I'm going to go through and actually cancel my denominators out. Okay? So canceling on the first term, the x cancels. So what do I have left? I have 8. I had 4 times 2. The second term, cancel the 2. Good, so plus 5x equals, good, the x's cancel, and I have negative 22. Don't lose that negative sign. Savannah? I would. So we'll subtract the 8 over there. So we get 5x equals negative 30. So x equals negative 6. Don't forget to check for any extraneous solutions. Right, sometimes you have to go back if you cross it out as heartily as I did. Yeah, your only restriction was 0, so that's a good answer. Correct, because if you did top and bottom, that cancels itself out. So in essence, you did nothing. Number 3. Now, I will tell you the cross-multiply method, you could never use that method ever. You could do every solving problem like this, if you really wanted to. So the cross-multiply problems, I find it's easier to cross-multiply. But if you don't like it, you could do them all like this. Don't matter. So, number 3, step 1, factor denominators. Does any of those factor? No, none of them factor. What's the LCD? This is the one that students typically trip themselves up on. Savannah? 3x is part of it. Oh. You said the 2 part, Lou? That's where most people try to go with that. That's a common mistake. That's it. This is held with the plus sign, right? So what do we know about stuff held with the plus sign? Can I break it apart? No. That's an entire piece all by itself. So I need a 3, I need an x, I already said the 3, and I need an x plus 6. X plus 6 is one piece. I can't pull that apart and just multiply it by something by a 2 and make it a 6. I can't do all that. So I need a 3, an x, and an x plus 6. 3x, x plus 6. 3x, x plus 6. When in doubt, did you cover every piece that's in the bottom? Don't get fancy with it. Just cover every piece. Make sure they're all written down. Okay? So did I keep it balanced? Did I do it to every single part? Yep. So then I can go through, cancel out those fractions. So I cancel out the 3x. What do we have left? 2x plus 12. Yeah, remember you were multiplying by the LCD, so you're going to actually distribute that. Okay, the next part, take out that 3. No. So everybody take a look. Right now, you have a 2 and an x on the outside, which is just 2x. So just distribute 2x throughout the whole thing. Does that make sense? Just 2x. So 2x times x is, oops, wrong sign there. It's 2x squared. And then 2x times 6 is 12x. And then the last term, questions on what we did so far? Alivea, you want to grab your notes from Wednesday and try to jump in, hun? That's what? So from here, I can clean up the one side. Over here I have 2x squared plus 14x plus 12 equals 24x. Do I need to set this equal to 0? Do you have an x squared? Yeah, so then I need to set it equal to 0. So we'll get 2x squared. Subtract that over. Gives me negative 10x plus 12. How do we factor that? Take out a 2. So x squared minus 5x plus 6. The dreaded 6, 5 combo. Is it 1 and 6 or is it 2 and 3? Oh, I heard different answers. Let's talk this way. What are my signs? They're both minus. So if they're both minus, it has to be 2 and 3. If that last one's negative, my signs are the same. So they're going to have to both be minus. So that means I need 2 and 3. So what does x equal? 2 and 3. Wait a minute. What were my restrictions? 0 and negative 6. So my answers are, they're good. It's not a correct or wrong. They're good or they're extraneous. All right. How we feeling? I know we're exhausted. It's Friday. It's been a weird week. Is it making sense? For the most part, it looks like most of you at least. All right, number 4. Step 1. Factor denominators. Yes, take an x out. So x minus 2. So step 2, find your LCD. What is the LCD? I need an x and I need an x minus 2. Yeah, because I can't cancel that x with an x minus 2 because x minus 2 is one piece. They're held together with that minus sign. So I need an x and an x minus 2. And we put that on everything. Do you see why it's beneficial to actually write that on every single piece? I have students every year who are like, I can just figure it out, and like they just kind of wing. I'm like, you're losing things. Okay, even myself, who does math all the time, thinks this is fun and likes to do this, I still write them all down. Maybe it's just because I like to cross things out. It's kind of fun. All right, so on the first term, what cancels? Yeah, the x and the x minus 2 are going to cancel out. So I just have 10. And then I got a plus sign. What cancels in the next one? Just the x. So good. 4x minus 8. You have to actually distribute that. Equals. The x minus 2 is canceled. And I have just 5x. See, isn't it fun to cancel out? Makes you feel like you really did something. Because then you get down to like, look where we're at compared to where we started. It's almost ridiculous how much easier that looks. All right, I have some like terms. 10 minus 8 is 2. Set equal to 0 or no? Nope, I can just solve. Subtract 4x over here and I get x equals 2. What do you mean but? 0 and 2 were my restrictions, so this has no solution. I love that you guys get so excited to be like, ha ha, can't do that. Wrong, right, Nate? But LCD makes sense and how we're canceling. Make sure you do it to everything, right? Got to be fair. Actually, what number is this on your page? 5. Maybe just do 5. So, number 5, there is a slight change. So please make this change on your paper. I know it looks very similar. I changed 2 things on it. The original problem, this was a plus. Change that to a minus for me. And your original problem has x minus 1. I want it to be 1 minus x. I know it's coming in the future, and I want you to see it. So I want to try to make sure that you know how to handle something like this. What? Look at my problem, look at your problem. See what's different. What? Yeah. Yep. All right, let's go nice and slow through this because I know the mistakes people make, and I want to make sure I draw your attention to them. So right away, step 1, well, even before step 1, Brittany had already mentioned it. You see the minus sign? What do we usually do with the minus in between there? Yeah, let's change that to a plus and distribute it up top. So I'll change that to a minus up there. Can you what? Carrie, yes, you can, but I'm not going to teach it that way. Because it doesn't always work that way, and I want to, but you're right, you're probably looking ahead and you can see what's happening there. Yeah. All right, so right now, what is wrong with the bottom? That's 1 minus x, not x minus 1. It's not in standard form. So what have I always told you? If it's not in standard form, what do we need to do? We got to write it in standard form. So that's negative x plus 1. Do we like the first term negative? Because it was 1 minus x, so the x had a minus in front of it. So when I rewrite it, make sure you change the problem on your paper. Because I changed this problem on purpose. So when I go to factor, what should I do with this? I should factor out a negative 1 to make that x minus 1. And then the other denominator, x squared minus 1, how's that factor? X plus 1, x minus 1. So right now, what are my restrictions? Plus or minus 1? I'll make a note before I cross everything out in a minute. My restrictions are plus and minus 1. All right, what's your LCD? Very nice. I need a negative 1, an x plus 1, and an x minus 1. Because I've got to get all of those to cancel. So I need a negative 1, x plus 1, x minus 1. I know it's obnoxious to write it, but it really does help. Yeah. Not without taking a shortcut that I'm afraid that at this point in your math career is going to be too much for you. I mean, you can, but the reason I do it is so that I can physically see I'm canceling this denominator, canceling this, so here's all I have left so I can multiply them. I just think it's easier to not lose things. All right, so on the first term, what's canceling out? The x plus 1. So be careful. What do you actually have left now? I have a 2, I have a negative 1, and I have an x minus 1. So what am I multiplying? What's 2 times negative 1? And I have the x minus 1. Do you guys see where I'm pulling that from? Looking at what I have left, I have 2 times negative 1, which is negative 2. And I still have the x minus 1. So that's what I'm distributing. Negative 2x plus 2. Okay. Hold on. So on the next one, what are we canceling? The negative 1 and the x minus 1. So you have negative x and x plus 1 left over? Nope. Nope. That's why we changed that to a plus, so I don't have to worry about doing stuff like that. So then I get negative x squared minus x when I distribute that. And then the last part? Yeah, these are going to cancel, and then you just have 2 times negative 1, which is negative 2. All right, talk to me if I lost you anywhere throughout all of that. sometimes it's easier when you get a lot of pieces like that. Did you see how I kind of did my own little like side note? Like, okay, I have this and this. Okay, now I can distribute. Like sometimes we can't always just visually see it to distribute it. If you need to write it down, then write it down. Okay, don't lose things. Well, that's just where I'm at right now. So let's go ahead and clean it up some. So I have negative x squared. Negative 2x minus x is negative 3x plus 2 equals negative 2. Do I need to set this one equal to 0? Yes. So I'm going to move everything to the right because I don't want to deal with that negative x squared. So that comes over as positive x squared. The negative 3x moves over as a positive 3x. The 2 moves over, and what do I get? Minus 4. Thank you for not telling me it cancels. Every year, somebody's like, oh, they just cancel out. No, they don't. It's minus 4. Does that factor? Good. X plus 4, x minus 1. Which means x equals, good, negative 4 and good. Way back in the beginning, I made myself a note before I scribbled all that craziness out. Plus and minus 1 were my extraneous, so that one's no good. So x equals negative 4. Absolutely. I would actually prefer to see that so that I know that you got the right answers and then you recognized it was extraneous and crossed it off. Yeah, if you look at my answer keys, all mine say like x equals negative 4, 1. I'd have a big old x crossing out the 1. So something that shows me that, like, yes, I got that, but I recognize it's not a good answer. Number 6. Last one, right? Can you try this one on your own? All right, go ahead and try it on your own, guys. So step 1, factor denominators. Did we have to do that? Nope, didn't have to factor them. Step 2, what's your LCD? Good, I need both parts. So x plus 4, x minus 1. X plus 4, x minus 1. You have to write that on every term. Okay. Hopefully we got to that point. Some of you forgot that 4 in the middle. All right, step 3, multiplying by the numerators to cancel the denominators. So from here, you're trying to cancel everything out. So in the first term, the x plus 4 cancels. So you're going to have to distribute and get 6x squared minus 6x. Okay? The next one, nothing cancels. Now the question always becomes, how do you multiply that? So let's just do a side note, shall we? Side note. If I gave that to you and asked you to multiply it, how do we multiply that? Lou? Okay, that's one option. Brittany? Mm-hmm. Good. And that's probably the way I would go. Lou, what you did is not wrong by any stretch. Just because I've taught you already so far this semester, we start with the back two. Multiply those, bring down the next one, and then multiply. So we're going to get x squared minus x plus 4x minus 4, just distributing this. So then that's x squared plus 3x minus 4. Drop down the 4, and then we multiply that one through. So 4x squared plus 12x minus 16. So where does that go in my problem? Yeah, it goes right after this. Because that was me trying to figure out what all that was. That goes right here in my problem. 4x squared plus 12x minus 16 equals. And then over here, the x minus 1's cancel. What do I do with those? We distribute those together. So another side note, if I can get this thing out of the way. All right, second side note, I have 2x plus 2 times x plus 4. So we'll distribute those. So 2x squared plus 8x plus 2x plus 8. 2x squared plus 10x plus 8. Where does that go? After my equal sign. Cool. What's probably a good idea from this point? Let's combine our like terms, right? We got a lot of stuff going on over here. So 6x squared and 4x squared is 10x squared. Negative 6x plus 12x. And I have minus 16 equals all of this. Do I have to set that equal to 0? Yeah, you get an x squared. So I'm going to subtract this over, get 8x squared. Subtract the 10x, gives me negative 4x. Subtract the 8, gives me negative 24. Good. Now I need a factor. Take out a 4. So 2x squared minus x minus 6. And factor that further. My signs are plus minus. Options for A. 1 and 2. So 1x and 2x. I'm going to go 1 and 6 or 2 and 3? 2 and 3. I know the 2 can't go there, so it'd have to be the 3. So it's 4 when I start my signs are backwards. So what does x equal? Negative, there you go, negative 3 halves. What were my restrictions? So my two answers are just fine. Now, that problem was about the hardest one I will probably give you. Really, it's a lot of multiplying. There's a lot of stuff that you can really kind of mess up along the way. Yeah. So, questions on the process. Do we understand the LCD? And now we have to multiply by every single term, right? We can't skip one. Okay. Do we get that part? All right, here's what we're going to do. The rest of class time, I'm going to give you guys your homework, give you time to work on it. I will set my answer key out, so as you're working, you can check. Because I know it gets frustrating when you get stuck in a problem. Okay, if you need help, please ask. If your phone is up front, grab candy.